Have you ever wondered how mathematical operations are performed in Java? This question brings us to the heart of today's topic, the Java math class. Now, every Java programmer is familiar with the java.lang package. It's the default, automatically imported into every Java program. Within this package, we find our star of the day, the math class. This class is Java's built-in tool for performing mathematical operations, a kind of math wizard if you will. It comes loaded with methods such as POW, SCART, CBART, ceil, floor, round, abs, max, min, and random. Each of these methods has a unique function that we'll be exploring in detail throughout this video. From powering and routing to rounding and generating random numbers, the math class has got you covered. So, sharpen your pencils and clear your minds. So, are you ready to dive deeper into the math class? Let's begin. First off, let's tackle the power and root methods, POW-XY, SCART-X, and CBRT-X. The POW-XY method is a powerful tool in the Java math class. It's designed to raise the base x to the power of y. Imagine you're building a tower of bricks. X is the base of your tower, and y is the number of levels you want to stack. If you want to stack 3 levels on a base of 2, you'd write POW 2, 3, and Java would give you 8, the total number of bricks in your tower. Next up is the SCART-X method. It's like the friendly neighborhood square root operator from your school days. It takes a number x and gives you the value that, when multiplied by itself, equals x. For instance, if you wanted to find the square root of 25, you'd write SCART 25, and Java would return 5. Why 5? Because 5 times 5 equals 25. It's as easy as that. Last, but certainly not least, we have the CBRT-X method. This one's a bit more specialized. It calculates the cube root of x. Think of it as the SCART-X method's bigger sibling. Just like the SCART-X method calculates the square root, the CBRT-X method calculates the cube root. So, if you write CBRT 27, Java will return 3, because 3 times 3 times 3 equals 27. It's essential to remember that all these methods return a double value. So even if you're dealing with integer values, you'll get a double as the result. That's just how Java rolls. These methods can seem a bit abstract at first, but they're incredibly handy tools in your Java toolkit. Whether you're calculating the hypotenuse of a right triangle or figuring out the volume of a cube, these power and root methods have got you covered. And that covers our power and root methods. Simple, isn't it? Next up, we have the rounding methods, ceilx, floorx, and roundx. These 3 methods are the unsung heroes of Java's math class, smoothing out the rough edges of our number crunching. Let's start with the ceilx method. The term ceil is a shortened form of ceiling, and just like a ceiling is above us, the ceilx method rounds a decimal number up to the nearest integer. For instance, if you have the number 4.3 and you apply the ceil method, it will give you 5. It doesn't matter if the decimal part is 0.1 or 0.9, the ceil method will always round up. Next, we have the floorx method. As you might guess, floor is the opposite of ceiling. This method rounds a decimal number down to the nearest integer. So if you take the number 4.7 and apply the floor method, it will give you 4. Whether the decimal is 0.2 or 0.8, the floor method will always round down. Last, but certainly not least, we have the roundx method. This method doesn't take sides. It simply rounds to the nearest whole number. If the decimal part is less than 0.5, it rounds down, just like the floor method. But if the decimal part is 0.5 or more, it rounds up, just like the ceil method. So if you have the number 4.4 and apply the round method, it will give you 4. But if you have 4.5 or more, the round method will give you 5. These rounding methods are incredibly useful when you need precise control over how your numbers are rounded. They can help avoid errors and unexpected results in your calculations. With these methods, rounding numbers in Java is as easy as pie. Now let's move on to some other useful methods: abs A, max A, B, min A, B, and random. Starting with abs A, this is a straightforward method that returns the absolute value of any number A. An absolute value, as you might remember, is the non-negative value of a number without considering its sign. This means that abs -5 equals abs +5, which is simply 5. It's a handy method when you need to work with the magnitude of numbers and disregard their negative or positive nature. Next, we have max AB and min AB. These methods are like the referees of the Java math world. They take in two numbers, A and B, and return the larger or smaller number respectively. So, if you ask max 3 7, it's going to tell you 7, because 7 is greater than 3. On the other hand, if you ask min 3 7, it will return 3, because 3 is less than 7. It's as simple as that. Now let's discuss something a bit more fun, the random method. This method generates a random number, but not just any random number. It returns a double type number that is greater than or equal to 0 and less than 1. So if you ever need a random number between 0 and 1, random is your go-to method. You might wonder, when would I ever need such a thing? Well, the random method is often used in game development, simulations, and testing, among other things. In summary, abs A gives you the absolute value of a number, max AB and min AB return the maximum and minimum values between two numbers, and random generates a random number between 0 and 1. With these methods, you can perform a variety of mathematical operations with ease. Finally, let's see how we can use all these methods in Java expressions. This is where the true power of the math class comes into play, allowing us to create complex mathematical expressions with ease. Let's take a simple example first, calculating the area of a circle. We know the formula is pi times the radius squared. In Java, we can write this as double area equals sign math pi asterisk math.pow radius 2. Here, math pi gives us the constant pi, and math pow radius 2 squares the radius. Now let's say we want to find the larger of two numbers and then take the square root of that number. We can achieve this in a single line of code using the max and scart methods. Double result equals sign math scart math max num1 num2. Here, math max num1 num2 returns the larger of the two numbers, and math.scart calculates the square root. But we can go even further. Imagine we need to calculate the distance between 2 points in a three-dimensional space. This involves finding the square root of the sum of the squares of the differences in the x, y, and z coordinates. In Java, this becomes double distance equals sign math.scrt math.pow x2 x1 2 plus math.pow y2 y1 2 plus math.pow z2 z1 2. And what if we want to generate a random integer between 1 and 10? That's where the random method comes in. We can use it with the floor and ceil methods to achieve this. Int randomnum equals sign int math.floor math.random 10 generates a random decimal between 0 and 9. Math.floor rounds this down to the nearest whole number, and plus 1 ensures the result is between 1 and 10, not 0 and 9. These are just a few examples, but the possibilities are endless. By combining the methods of the math class with Java's operators, we can create a wide variety of complex mathematical expressions to solve real-world problems. And that's how you can use the math class to write complex Java expressions. So, there you have it, a comprehensive guide to the math class in Java. We've explored the depth and breadth of this default package, diving into the various methods it houses. From the power and root methods such as POW, scart, and cbart that allow us to perform exponential and root operations, to rounding methods like ceil, floor, and round ensuring precision in our calculations. We've also delved into other useful methods like abs, max, min, and the ever-elusive random method. Each one of these tools aids in creating robust and dynamic Java programs. And let's not forget the application of these methods in Java expressions, a key component in writing efficient code. In essence, the math class in Java is a treasure trove of mathematical methods ready to be harnessed. Remember, practice makes perfect, so go ahead and try out these methods in your next Java project. Happy coding!